Welcome, everybody. Just so everyone is aware, we are already recording the meeting. So if you do unmute to ask questions throughout, just know that that'll be recorded in the training, and we do encourage that because whatever question you have, other folks probably have it. So feel free to chime in as we go. But first off, just to get us started with introductions, my name is Julianne Wilder. I think most of you are familiar with us, but I work for the Northeast Fisheries Science Center with Genevieve, and also do some real-time analysis for Mark through Hui. And so I do mostly the real-time stuff and LFDCS trainings and data management at this point. But Jen, you want to go?
Sure. And hi, everybody. I'm Genevieve Davis. So I work at the Northeast Fisheries Science Center with Julianne. And then, of course, we work closely with Mark, mostly on LFDCS stuff. And so have used it widely and are excited to share it further today. Mark, do you want to go?
Sure. I'm Mark Baumgartner. I'm a marine ecologist at the Woods Hole Oceanographic Institution. And for the purposes of this training, I'm the author of the LFDCS, for better or for worse. So glad you're all
for
here.
better now. All right, we will go ahead and dive in. I'm going to share my screen here so we can all see the agenda. Can everybody see that? Excellent. Okay. So just a quick run through of what we're going to be doing today. Jen is going to start us off with just an introduction into LFDCS 2.0. So just an explanation of how the new version differs from the old version, what's available now. And then I will dive into the actual programs, go through the reference guide, show the distribution file and what files are included in that, and then go through the various programs and try to do it in order of how most users would probably use the programs through LFDCS. And we also have some additional resources here that we'll go through as well. We'll have a couple of breaks in between things. We're going to end the training with the creating and managing call libraries programs because a lot of folks won't actually need to use those. We have the GOM9 and other call libraries available for people to use. And so most folks won't need to create their own call library. So feel free to pop out of the meeting if that doesn't apply to you, or hang out if it does, or if you're interested. So with that, I think, Jen, do you want to go ahead and?
Absolutely. Yes. So I think many of you are familiar with LFDCS in general. And just to start, so this is the low frequency detection and classification system that Mark created and wrote like 15 years ago now at this point. And as he always tells us, he wasn't expecting so many people to use it. But because it's so versatile and easy and fast and works, and it's the only reason really we're able to get through. We turn around 50 recorders every 5 months and are able to be mostly up to date on analysis because of it. And so from that, it's really exploded, and more and more people using it. And we've migrated from LFDCS 1.0 to 2.0 version to be a little more versatile. And so what 2.0 brings to you is that you're able to use it on any platform. So our computer software. So before, LFDCS was limited to Mac computers only, and now it operates on Windows, Macs, and Linux machines. It's also available now by only needing an IDL runtime license, which is just under $500, versus before you needed a full IDL license, which was about $1,500. And then what's really exciting about the new version is we have GUIs or UIs. So a window will pop up for every program that you can use that Julianne will go through, and you can fill in the boxes for each value. So before, it was terminal run, you had to open it up, you had to know the different syntax for each program, and now you can just open up the UI and follow the prompts that way. So it's a little bit more straightforward, and there's a reference guide for this as well that Julianne will show you to help walk through everything and really spell it out too. So hopefully it's as clear as can be. So you can just take it and run with it.
Thanks, Jen. All right.
Julianne, if I could just jump in real quick to add to what Jen said. So for those of you that are using the Mac version of LFDCS, the full version, there's nothing different. Like when you process your data, there's nothing different between that and LFDCS 2.0. So don't feel like you need to migrate if you're already happy with LFDCS 1.0 on your Mac. You can continue to use that software and you'll be doing exactly what everyone else is doing with LFDCS 2.0. There's nothing different about the actual processing.
That's a good point. And just to emphasize that, we did a lot of testing between the two versions and comparing outputs and making sure that everything is identical also across the different computer operating systems. So you should have no fear in using whichever version that you have.
Wonderful. Thank you both. Okay, so we'll dive in, and feel free if anyone has questions as we go, just unmute, interrupt me. We can get things answered. We will also have a Q&A at the end of this section before we get into the call library stuff. Actually, we might take a brief break before we go through the data browsing portion. So there will be opportunities to ask questions as well. But if there's something immediate, feel free to unmute. So I'm going to start off with just a little introduction to the distribution file. This is the Google Drive link that was sent out in the email to the LFDCS users listserv. And you can request access. We'll make sure that you get approved. Just request access through Google Drive. And so what's included in here is a PDF of the LFDCS 2.0 reference guide draft. This hasn't actually been published yet. It will eventually be published as a NOAA tech memo, similar to the first version. So just be aware that there may be a couple typos here and there. It will go through an editing process. If you see anything glaring, feel free to let us know. We always welcome feedback, especially if there's sections that you feel like are confusing or anything like that. So please let us know. But it will go through an editing process. In addition to that are the actual distribution files. So for version 2.0, we have two distribution files here. This is kind of the main one down here. And then we have the supplemental Soundtrap test data set as a separate file, just because it's a bit larger. So the installation process is simply to download these files and unpack them in the same location on your computer. And what should happen is the Soundtrap test data set will embed itself in the file structure of the kind of original distribution file automatically, as long as you're unzipping them in the same location on your computer. So for example, here, we have multiple users that use our PCs, and this whole training will be displaying the PC version, but this is also available, as Jen said, on Macs and Linux computers. But in this case, it'll just be Windows. So if you have multiple users on the same computer, we do recommend putting it under your public folder under users, and that way it doesn't need repeated installations for each profile. And so I've stored mine here under public documents and unzipped it in that location. So it'll unpack. And once you unzip it, you should see, I put the reference guide in here manually, but you should see these 4 files when you unzip it. The bin and DLM, you shouldn't have to do much with those. Those just they contain like the program files. Actually, the process folder contains the program files. But this supplemental folder is the one that you might be working out of the most as far as accessing the actual files. So we have a call library folder here that has copies of this. This bottom one here is one that I added, but you will have copies of these top 3 call libraries. So these are ones that we've already built out. There's a broadband call library, which we currently aren't using LFDCS for broadband sounds, but it does potentially have that capability. So there is a broadband call library there. There's a narrowband GOM9 call library, which is the most recent version of our baleen whale call library that we use mainly for, say, North Atlantic right whales and humpbacks. And then we have a call library narrowband for GOM low frequency that we use for blue whales and fin whales. So those are there for you to use. If you want to do any call library editing, I definitely recommend making a copy of this file and then working on the copy. That way you still have access to the original. So there's call libraries there. There are example parameter files. So these are, as most of you are probably aware, these are the parameter files are essentially your detector settings files. So they're what you edit to prepare for processing your data. And so in the Davis et al. Folder, there are the files that are examples of what Jen used in her PhD project for the migratory corridor. And so you can access those if you want to kind of mimic the same settings that she used. You're welcome to use those. There's also some Soundtrap specific examples. There's one here for 2 kilohertz data. There's another one here where if you're wanting to reprocess and downsample to your low frequency data for fins and blue whales, there's an example of how to do that here. And then there's an example parameter file for if you want to downsample to the low frequency range straight from the raw audio. So this middle one is like if you've already sampled down to 2 kilohertz and you want to go even lower. So there's some examples there. The test data set. We do have 2 test data sets available in this supplemental file. So these are just parameter files that are set up as examples for how you might process those test data sets. There's one for the Maru test data set and one for the Soundtrap test data set. You will need to, when you go into these, you will need to edit your file pathways. So I'll get into that in more detail briefly. Okay, program presets. So these are, you won't have the Julian examples folder, I added that, but you will have the rest of these when you download the distribution file. So these are just a few program presets, preset files that we've provided for folks to kind of work off of if it's helpful for you. So when you open up the program windows to select, to set up the program that you want to run in LFDCS, which will show all of that shortly. These are the files that you can select that kind of have these, it's like Raven presets. So it's like, you know, you have your settings already established, so you don't have to redo it every single time. So I'll show how to access those through the program window. References and training. So there's the original LFDCS paper that was published, and then there's a document here that takes you to the it just provides the link to the Robots for Whales resource page where you can access the reference guide and the training info. The LFDCS 2.0 reference guide is not currently on the Robots for Whales website yet. We're going to wait till it gets published as a tech memo, and then we'll post that link. But for now, you can access it. It's provided when you download the distribution file. And then there's some tutorial slides. So these take you through some of the background of the algorithm. So Mark provided those if you want to get a little more detail there. And then finally, we have the test data sets. So within these are the Maru test data set. So when you process an LFDCS, when you process a data set through LFDCS, you'll get your processed folder. You'll make these ahead of time. So raw, this is an example. You don't necessarily have to use the words raw or processed, but that's how we've always set ours up. So raw is where we put our raw audio files, and then we make a processed folder and we direct the LFDCS to put the processed data here. So once you process a data set, you'll get an LFDCS folder and a spec audio folder. And the LFDCS folder is where all of the pitch track information is stored. So we'll take a look at pitch tracks momentarily. I think most folks here are familiar with it, but we'll go over pitch tracks briefly. They're essentially contour lines that trace the sounds in your sound files. So all the pitch track data lives there. And then your spec audio files, those are essentially like spectrogram images that LFDCS creates itself. So usually these take up quite a bit of space. Once you're done analyzing a data set, you are welcome to delete the spec audio file to just free up storage space. You can recreate it if you want to. But this is where all your spectrogram images live once you've processed your data set. We also have the Soundtrap data set, same thing. We have a process data here and the raw data there. And I'll show you how to actually process a data set shortly. So also, before we really get into the programs, just a quick introduction into the LFDCS 2.0 reference guide. So this is going to look somewhat similar to the original version that is published in the NOAA repository. And so you have your table of contents here. The first part one, this first half of the document, that's all the LFDCS desktop. So the 2.0 version, we don't have any of the old information on LFDCS, the original version here. If you want to look up, like code examples or whatever you need for if you're still using the original version, you're welcome to go back to the old reference guide that is published online. So here it's just the LFDCS 2.0 programs described. And then we included the real-time analysis protocol again as part 2. So that is going to look pretty similar to what was in part 2 of the original reference guide. So a couple of things, there's some background here, some contact information for us. We also have the listservs. So especially this LFDCS users listserv, which I think most of you have been added to at this point, is a great resource if somebody just has a general question, if you're trying to do an installation and it's not working, or you're trying to, figure out how to use a certain program, and you have questions about how to do that. We really encourage folks to email the LFDCS users at hui.edu listserv, because it really helps us. A lot of people come to us with similar questions, and it really helps create a community where we can kind of crowdsource the answers for those and make sure everybody's on the same page. So a little introduction into pitch track. So this is kind of one of the main features of the LFDCS is pitch track generation. So you have your sound file, your raw audio here. We have a nice example of some humpback song. And when you process your audio through LFDCS, it's going to draw pitch tracks or contour lines through any sound that's typically it's 10 decibels or more above background noise. So you can see some of these didn't get caught. That's probably because when the screenshot was taken, there was a filter put on the Mahalanobis distance, which we'll get into later in the training. So it's filtering out some of the other sounds, but some of these pitch tracks came through. Usually the one that you have selected actively is the one that's in color in the middle here. And so when you're looking at a selected pitch track, you're going to see the different colors. It's indicative of amplitude. So warmer colors indicate louder sounds, cooler colors indicate quieter sounds. So they're essentially just lines tracing the sounds in your files. A couple other things to highlight here. There's installation instructions for the different types of computers that you might be installing this on. So good to know there. And I do want to highlight for folks using Windows computers, there is a file configuration in the DLM folder that you have to do. It's really easy. It's just essentially selecting a directory. But you do need to do it for your audio to be able to work with the program. So don't forget about that part. It's just a couple pages there. A few basics. So we have the LFDCS app launcher. So when you install your distribution file, you can go into your process folder and scroll down, and you should see this LFDCS app launcher file. And what we recommend, just for easy access, is to create a shortcut of this file and plop it onto your desktop, which is what I've done here. And so this is the main way that you're going to be accessing the LFDCS 2.0 programs. And as Mark said, these programs, once you open them, they are all going to operate and actually look pretty much the same as the original version. It's the way that you're accessing them and inputting the settings that has changed. And we've tried to make it easier so that instead of writing out code, you're going to be inputting information into program windows and using a GUI instead. So it's hopefully a little more user-friendly. So for example, we can open the reformat to detect classify program here. So you can see a lot of the program windows look similar to this. So the app launcher is how you access all of the program buttons there to select whichever program you want to run. And a few common features here with each program window. Some of the fields are required, others are not. Any required fields are going to have an asterisk. And so those are going to be ones that you have to input some kind of information into before you can actually run the program. You might be able to click OK and still run it, but it's going to give you an error if you don't have your required fields filled in. So just a note about that. There are some log file fields down at the bottom here. I'll zoom in a little bit. So at the bottom of each program window, there's a couple of fields here. So your log file, that's essentially a file that is kind of like the terminal window where it kind of shows you the inner workings, like what's happening in the background when you run whatever program you're using. So if you want to save, kind of the nitty gritty of how your program ran, we don't typically do this. We don't really worry about it. But if you do, you can select the location and name your log file and select wherever you want it to save on your computer. And then there's this option down below, append log file. And if you select true here, it will, if you run this program a second time after creating an original log file, it'll just keep adding to that original log file rather than creating a new one. If it's the first time you're running it and you want to do it, you will need to select a location and name your log file for the first time there. So just a heads up about that if you are interested. There's a few buttons at the bottom, which are, this is self-explanatory. You can click OK to actually run your program once you've filled out all your settings. You can click cancel and it'll close out your program window if you change your mind, you don't want to run it. And there's these save as, restore, and restore from buttons. These are your buttons for saving your program settings and restoring or accessing your program presets when you go back in to run your program again. So when I talked about those program preset files that are stored in your supplemental folder, these ones here, that's what you can access and restore so that you don't have to fill all this information out every single time you use it. So for example, with this program, I could go in and manually select all this stuff. Obviously, I have to do that when I originally run the program, or I could select one of these. But if you want to use the presets, you just click restore from. You can navigate to your presets. And these are ones that I've created just for this, for examples for this training. So you can find we're doing the reformat, detect, classify program. So we can select one of those. So let's go ahead and do the Maru data set. For this, really, to actually process a data set, you really only need your parameter file selected. And so that's what you can see here. So I'll go in and we can explain the parameter files now so you can understand what those are and how we set them up. Oh, yeah, I'm in the wrong place. Let's do this. Okay, so this is an example of a parameter file. Let me see if I can make this a little bit bigger. So this is essentially where you type in the instructions for how you want your data set to be processed. So some of these fields, and this is all explained in the reference guide in the appendix, some of these fields are just metadata fields. They don't impact how your data actually processes. They're just kind of information for you to, you know, track how you're processing things or which data set you're working on. But others do actually impact how your data is processed. The only fields that you're going to be editing are these top ones. So everything from call library file, BB, that's broadband, and up, those are the ones you're going to edit. You can edit these bottom ones, but we've really already kind of set them to as ideal of settings as we could possibly get them for the spectrogram images. So we don't recommend editing these lower fields because they're going to mess with the data. And we do have different settings for if you're looking at like a 2 kilohertz sampled data set versus like your lower frequency. Like if you're only wanting to look at, 0 to 60 hertz for blue and fin whales, there are different settings for those down below. So that's why we have examples like here, so that you can basically just make a copy of one of these parameter files. And if you're wanting to do like a low frequency data set, you can make a copy of this one, and that way you have the right settings. So just be aware to make sure you're making a copy of the right parameter file depending on your data set before you get rolling. Okay, so just a quick run through of the fields here. Under experiment, this is a metadata field. It's not going to impact how your data runs. It's just going to be, whatever you want to title your project as or your data set. In directory and out directory, those definitely do impact your processing. So this is where you select your in directory, where you want your, this is where you show the LFDCS where your raw audio files are. So make sure you have your pathway there. If you're on a Windows computer, I'm pretty sure you're going to need your hard drive letter at the beginning there for it to actually work. So just a note about that. Your out directory is where you select wherever you want your process data to output to. This will not impact your raw audio. So your raw audio files will be safe. They'll stay the same. They're not going to be impacted by processing through LFDCS. It's going to create the LFDCS and spec audio folder in your processed folder. And that's going to be your new, LFDCS files. So you don't have to worry about your raw audio being impacted at all. Start date, you can basically just leave this as is unless you're processing data from before 2006. Your start date just needs to be prior to the start date of your data set. So you can really just leave this date as it is. Platform type.
Julianne, can I just emphasize what you just said? Start date is one of those things that I slightly regret ever having put into this parameter file. This is something, as Julianne said, you just have to set once and never set again. Just set it to some date that's before all of your recordings. So even if you set it to January 1st, 2000, January 1st, 2010, doesn't have to be January 1st, it could be whatever you want. But just set it and forget it. So I just wanted to emphasize that because this start date kind of trips people up sometimes. Thanks, Julian.
Well, yeah, we used to have it as like 1970 or something. Oh yeah, Courtney, go ahead. Oh, sorry, Jen.
I think that's what my question was going to be. If we want to process data before the year 2000, would that mess with the 2-digit?
No, that's fine. So what this really is, if you're like a computer nerd like me, this is something called an epoch. So with computers, there's typically a couple of different epochs that are used. One is January 1st, 1990. Another is very common one is January 1st, 1970. So you could set those to those as well. I wouldn't set it to something before 1950 because I'm only using 2 digits for the year, and it's probably going to interpret that as 20. Like if you set it to 1949, it'll probably interpret it as 2049. So yeah, so if you're processing data before 2000, just set it to some date before.
And just one other thing. So what this does when you export detections, it uses this start date as the calculation time for start since in terms of the number of seconds to give you date time in that exported. And we'll see that later, but just so if you have an earlier start date, you're going to get more seconds in that column, basically, is just something to keep in mind as well.
Yeah, the details of this are that the LFDCS keeps track of timing as seconds since the start date. And so the closer your start date is to your actual start date of your audio, the less chance there is you're going to run out of seconds in that field. But for the vast majority of people, that's not a concern. You could set this to January 1st, 1970 and be totally fine. So I'll leave it at that.
Thank you. Okay, so these next fields are all metadata here. So platform type, platform ID, instrument type, and instrument ID. So here we have moored buoy, maybe it's a glider, maybe it's, whatever your platform type is, platform ID, and that's, whatever your group uses, as a naming structure for your platforms. Instrument type, this is the Maru test data set. So we have Maru here. And instrument ID, that might just be like whatever number is assigned to that unit. File extension.
Oh, no, sorry, wait. Instrument ID is the channel number. So if you have multi-channel data, this is where that actually does direct it to which channel to read in. So it's slightly, so the platform ID is whatever ID instrument number that you want to use, but instrument ID will give it to that channel in a multi-channel data set. If you have single channel data, you would set that to 1.
Thanks, Jen. I didn't know that. I always thought it was just the platform. Well, there we go. Okay, file extensions and file formats. That's just whatever your file type is. So for in this example, it's going to be a WAV file. File date spec, that's whatever format the date and timestamps are in your sound files. So you can edit that to match whatever that structure is. Originator, we typically use that field. This is metadata as well. So it's the originator field is not going to impact how your data runs. How we typically use it is we put the person's name is of whoever is processing the data set. That way, or whoever's analyzing it, usually it's the same person. But that way we can go back and refer to them if there's, something with the data or we have questions about how it was processed, whatever, that gives us a record. And how we do it at NEFSC is we create a copy of this parameter file for every deployment or data set that we process. And we have it named accordingly. Like this is actually a good example up here. So we have like NEFSC, the region, the year and month of the start date of the deployment, the platform ID or hydrophone ID. And so we have one of these for every single one that is processed. And we save those. We eventually delete them once enough time has passed, but we do save each one, which has actually helped us in the long run because sometimes, issues come up and you can't remember, which deployments were processed in which way. And it's really nice to have a record of how each one was done to help identify issues and things like that. So, so you might end up with a lot of copies of parameter files if you do that. Location, also metadata. It's not gonna, yeah, Jen.
Just one note on that. So it's okay if you lose the parameter files. You can go back into the process data and pull out what most of these settings were. I think there's like one thing we found that you won't see, but otherwise there is a program that Julian will show that you can read the data from the files that are written to be able to see what went into the metadata. So there is that too. So don't worry if you do lose them.
Yeah, definitely recreatable. Thanks, Jen. The location is metadata. It's not going to impact how your data runs. So just whatever region or location your recording was taken in. And then file duration. This is not the length of your WAV files. This is the length of the spec audio files that are produced when you process LFDCS. So it can help to have this. We used to have this be a little shorter, and then we eventually lengthened it because it does create like just a split between the spec audio files. And if you try to create a clip, like just, you know, take a clip of a recording and it spans over one of those breaks in the files, it'll create an error and you won't be able to create a clip that way. So we decided to make this a little bit longer, just so we don't run into as many breaks in the spec audio files. So that's your file duration setting. You can feel free to keep this as whatever it is in these test parameter files. And then we have some spectrogram settings here, which these you can mess with them if you want, but we also wouldn't recommend changing them. These are a little bit different between like the 2 kilohertz versus like the low frequency parameter files. So again, important to make sure you're making a copy of the right parameter file before you process your data, because we've tried to kind of just make these as good as we can get. Yeah, Courtney, go ahead.
Sorry, I may have missed this, but can LFDCS process FLAC data?
Yes, it does so now on Windows. I believe there's an issue doing it on Mac. So, and that's a Mac thing, being unable to handle FLACs. And Linux should be fine too. I believe on Linux you need an extra thing with IDL. It's like an extra type of reader that they have for FLAC handling. But I would say if you have FLAC files, try it. And if you have an issue, then if you can write the list with the question, then we can put the correct instructions so everyone can see how to contact IDL with the right thing that you need to get added to your license.
Okay, thank you.
Lovely. Okay. All right. So the last 2 fields that you will edit in your parameter file are the call library file field, which is where you will select the pathway to the location of your call library netcdf file. So this is wherever you have your call library files stored. Most of you are probably going to be using the ones that we've already created. So this would be like directing it to, for this example, it's the call library narrowband GOM9. GOM9 is for Gulf of Maine. It's just a name that we chose for the call library originally. Most of the exemplar call types that we use, or calls that we use, came from Gulf of Maine for these. So this is the file, this base one. So there's these ones that have these suffix, so like audio, exemplar, track. You're going to want to direct it to the one that doesn't have anything after it. So just call library GOM9 is what you can select there. And then you're also going to want, you're not going to be doing anything with broadband, but you do want to have a broadband call library file selected here as a placeholder. So if we click out CLBB, so call library broadband GOM, and again, just the base file, not these ones that have the extra text. So you're just going to want to direct it to that. So once you have your whole parameter file set up the way you like it, you can save it, make sure you know where you put it, and then you can go to your program window. So again, here, if we want to process a data set, you're most likely going to be using this first program, the Reformat, Detect, and Classify program. So if we click on that button, it brings up your program window. And I'll do this just for the example rather than using the program presets. For this one, the parameter file is the only required field. So you can go in there, go to your distribution file or wherever you have your parameter files stored. You may not actually be storing your parameter files in your distribution file, but for this example. Okay, so I've got my Maru test data set, all good to go. If you want to be able to do this again, you can click the save button, and that means it will automatically save it for, like, if you just want to hit restore, if you know it's going to be like the last one that you use that you want to bring back up. So if you want to restart your program here, you can click restore and it'll just pop it back up there for you. So you can do that, click OK. It's going to give you this little pop-up. It says, are you sure you want to convert the recorder data to netcdf? You're going to hit yes. Don't worry, this doesn't do anything to your raw audio. This means you're going to be creating some netcdf files. And you can see here in the log window that it is working. And this is a 3-hour data set from a Maru recorder. Yesterday it took 30 seconds. There we go, done processing. So you'll get a little pop-up window there. It's very satisfying. You'll get LFDCS processing complete with an exclamation mark and your time elapsed. So that is how you process a data set. There are a couple of options for reprocessing data sets if you need to. So you can use the reformat, detect, classify. So these are cases where maybe you want to process the same data set with a different call library, or you want to do a different version of an analysis on it, and you know, just whatever you want to do something different with your data set. You can use a couple of the settings here. So this create spec audio, if this is so this is if you've already processed your data set once and you have your LFDCS folder and your spec audio folder, and say maybe you want to you only want to like recreate your, I always get these reversed, you only want to create your LFDCS files, and so you would select no for that. Like if you want to keep your spec audio but reprocess your LFDCS files, be careful with this, because if you've done analysis already, you don't want to override, maybe you do, but in most cases you don't necessarily want to override all the analysis that you've already done. So make sure before you do this option to make a copy or put your LFDCS, your original LFDCS file in your process folder, put that in a different location so that when you run this, it doesn't override your original analysis results, because when you do analysis, it's automatically going to be saving to that LFDCS file. So just as a reminder, we're in like wherever you put your process data here. So it's going to recreate this LFDCS file. So just make sure you either rename this as something else or pop it into a different folder. There is another option here. So say you did your analysis and it was a while back, so you deleted your spec audio because you didn't need it anymore, and then you realized, no, I need the spec audio again because I want to look at it again. So if you want to keep the LFDCS folder that you originally processed with, but you want to recreate the spec audio, then you just say no for process with LFDCS, and it'll only recreate the spec audio files. So just a couple of options there. You can also do a version of this with the Reclassify Auto Detections program. This is, I think, a little bit faster in general if you want to just reclassify your auto detections. So maybe if you have a different call library, or if you've edited a call library and you want to reprocess that way. So here it's going to prompt you to select your index file. So that is located in your LFDCS folder of your process data. Here, let's go to test data sets, Maru, processed, LFDCS. And you'll see here, this LFDCS file index. You're going to select that one. And then it's going to want you to select a call library file. So say you're going to want to do a new call library. You'd navigate to wherever that is. So for this example, we'll just use DOM9 here. And it wants you to just take the base file. So select that one. You're all ready to go. Save it, maybe just in case if you want to like restore this later. Click OK. And done. It's reclassified your data. Obviously, this was done on a 3-hour data set, so it's quite fast, but it's still a pretty fast way to do this. A note about this, if you reclassify your auto detections that were originally generated when you processed your data set the first time, if you did analysis on those and scored some of those auto detections, maybe you're scoring them as like correct or incorrect or unknown or whatever, some of those scorings might carry over after the reclassification. So if you reclassify your pitch tracks and then go in and do more analysis, you might come across pitch tracks that still have like a correct score or an unknown score or whatever. So just keep that in mind, that that's not an accident. It's just a feature of the way the program runs. So you can change those scores if they don't apply anymore, or you can keep them as is, but don't be alarmed if you see some that you're like, how are these already scored? It's just from a previous, your previous analysis.
Can I just add to that? So this is, let's say you added a call type for another right well up call, for example, and when you reclassified your data set, sometimes a previous up call might now be classified as like a humpback whale upsweep or something like that. And so that's where we found, just to keep in mind, if you have already gone through and used the correct, incorrect, or unknown labels for detections, if that call type or detection gets reclassified to a different species or different call type, it still has that label on it. And so that's just where either you can go through after and look at those after reclassifying and clear the labels, or saving a previous output and then just reclassifying, doing it the way Julianne showed first, doing the reformat, detect, classify version. That would clear any analysis labels and kind of give you a fresh start. So there's just, depending on your goal for reclassifying and what you're doing, just a couple of things to keep in mind.
Thanks, Jen. Okay. So those are the basics for just processing your data set. So you're going to set up your parameter file and then direct either one of these programs, depending on your goals.
Hey,
to use
Julianne,
that parameter file. Yeah, Mark.
before you leave, I think you're about to leave processing and go to looking at results, correct? If you could you put the parameter file back up? I just want to say something very general about parameter files. So, as Julianne said, there's a lot of knobs in the parameter file that you can turn. So imagine if we were giving you a radio and it was tuned to a really great radio station, and we hand it to you and we turn it on and we say, look, listen, it's really awesome. You know, it's coming in crystal clear. You're like, okay, great. And then you go home and you fiddle with the knob, and then you turn it on and you're like, it's all static. And you're like, well, this isn't working. And then you come back to us and you're like, this radio doesn't work. Well, the radio worked when it was tuned correctly. And so the lesson here is that all those parameters down below, you're very welcome to fiddle with, but it's like detuning that radio. You're once you start changing these, you move into another realm of kind of detection classification, where it's up to you now to figure out what are the right parameters for your application. And that's a significant amount of work. So we, the collective we here, have done that work for you. If you're interested in doing detection classification of baleen whale species that are common to the, to the Western North Atlantic, we have other people that have worked, on the West Coast. So much of this work has been done for you. So if you want to fiddle around with these things, great, go for it. But just be mindful that it's not that you're on your own. We're happy to guide you, but you've embarked on something that will require a lot of work to figure out what the right tunings are. And so I just wanted to say that out loud so that when you go in, you're like, oh, I think this parameter should be changed. If you don't understand what that parameter is doing, that becomes sort of nightmarish for all of us, because you'll ask us, what's wrong with this? And it will take us a long time to figure it out. So if you do want to fiddle with these, make sure you understand what the LFDCS is doing very well. So you'll have read our 2011 paper on this, and you just have a very good basic understanding of how the program works. I'll leave it there.
Thanks, Mark. Another good reason to save your parameter files for a while, just in case, so that if you do process your data set, if you've edited any of these, it should be a little easier, at least at that point, to go back and look at which fields you changed, so that you can correct it if you want to go back to original settings. Yes, Jen.
Sorry, one more thing that we found. So if you did get rid of your spec audio for space, which is totally fine, and wanted to reprocess it in the future to be able to look at stuff or redo anything, we found you need to have the same start date specified in order for the audio to play with the previously done pitch track. So that'll just let everything flow as it should. So just to keep in mind, to remember, that's why having like a start date that you use for everything is really helpful so that it'll always work seamlessly. But just another note.
Thank you. Okay. We're gonna minimize that. Okay. Any questions at this point on data processing? We'll have more Q&A time later as well. Oh yeah, Manali.
Hi. Yeah, I know you said this at the beginning, but I wanted to confirm. So just for saving a parameter file that you, or like the settings that you want to reuse, you just click that Save As button at the bottom, and then you choose that location of where to save it. Is that correct?
Actually, that's a great question, Manali. So kind of two different things. The parameter files, those are just kind of their own standalone files that you can create like a parameter file folder that you just stick all your parameter files into. The save button that's at the bottom of the program windows, those are for the program presets. So that's different. So the parameter file is kind of your detector settings file. Your program presets are just the files that save your settings information for the actual program window itself. So that's where, like in our supplemental folder, we have a file for our parameter files here. So all of our detector settings, and then we have our program presets file that houses all of our things that just kind of like will automatically populate these fields to how you wanted or set them originally, kind of a thing. Does that make sense?
Yeah, thank you.
Okay, sweet. Yes. Yeah. So that's, yeah, you can save your presets here. That's not going to do anything with your parameter file. And then you can restore a preset file here and it'll repopulate your program fields. Okay. Let's go to, so as far as our process that we use at NEFSC, when we process an archival data set, we will run it through LFDCS. And then before we jump into analysis, we will export a summary sheet that will give us kind of a summary of the auto detections that were generated or the pitch tracks that were generated. And then it will also give us a space. We essentially use those as our data sheets for recording our analysis results as well. So I'm going to show you how to do that first, and then we'll take a short break, and then we'll get into the actual browsing of the auto detections. You'll get to look at pitch tracks. It's a little more fun than auto detection summary. So the program that we use for this is this export program, auto detection summary. So when we click on this, it's going to bring up your program window. You're going to select, so again, we have a few required fields here. This first one, you're going to select your index file. So this is after you've processed your data set and you're ready to do analysis. So you can go to wherever your processed data is and your LFDCS folder, and you're going to select your LFDCS file index NC file. Your call type list, that is where you list your call type numbers for the different call types that you want to export summaries for. And when I say summaries, it's mainly just like like how many auto detections were generated that got classified as that call type. So I will show you when I go through the call library stuff at the end of the training, I'll show you how to look up your call type list for a particular call library. For this example, we'll do the right whale call types, which are either 5 through 8 or 5 through 9. 10 is 9. Yeah, 9. Okay. Comma separated in the brackets here. And again, I'll show you how to look up, like how do we know that call type 5 through 9 are right whales? It's just part of the call library. Those are the numbers that are assigned. Most of these are just different versions of upcalls that were created. For the purposes of our analyses, we don't worry about whether a certain upcall was classified as call type 5 or call type 7. We just include all of them, And, you know, we just know that they're probably going to be picking up a right whale call types of, you know, just they'd have slight variations. So we don't really worry about nitpicking which call type number they were classified as long as they're all classified as like the same species. And then you're going to want to name and select a pathway for where you want it's going to output as a CSV file. So you're going to pick a name of where you want that, of how you want it named and where you want it to end up. If you just name it, so for example, like we can do like right whale summary. And for some of these, if they have the file extension in the parentheses here, that usually means that you do need to type it out in here. Otherwise, it won't process correctly. So include the .csv at the end. So if you just run it like this and you don't specify a file location, it should pop out in your process folder in the distribution file. So if you forget to tell it where to put it, look in your process folder after you've run it, because I think it'll pop up there. But in this case, maybe let's say we'll put it on the desktop. So select that, save, puts the pathway there. The next required fields are your time bins for how you want your auto detections to be summarized. So most of our analyses, we do daily presence. And so when we do our analysis, it's nice to have each row in the CSV file be for one day. And so you can do that in a couple different ways. You can do 24. So this is like the number of bins and then the bin time unit. So these two are related to each other. So we could say 24 hours to create daily time bins. You could do 1 and then select days instead. If you wanted, days. If you wanted to do hourly presence, you could do 1 hour and it would create hourly bins. So whatever settings you want to do for that, that makes sense for your analysis. So doing those settings. And then here, the start and end date are also required, because if you don't put those in, your CSV file will go on forever, and we don't like that. So you definitely want to give it some start and end points. And it helps if you kind of forget what the start and end times of your data set are, you can go to your process data set here. Oops. And I think usually the spec audio files, yeah, like these, it kind of takes you to, you know, the original names of your files. You can look at your raw audio, or hopefully you have it recorded in your metadata if you're recording things accurately. But check your timestamps there. So this is only 3 hours. I'll just do for the whole day because that's fine. We're just doing daily time bins. So this is, what is this, 9? Like that. And then we'll do just the start of the next day. It should give us, it's not going to be super exciting because it's only going to be 1 day's worth. So it should only be 1 row, hypothetically. Narrowband only, true, broadband only, false, because we're not doing broadband. So just leave those as the default. Maximum Mahalanobis distance filter. So your Mahalanobis distance, I'll keep talking more about that throughout the training, but it's essentially, it's a multivariate measurement of how closely each pitch track that is in your process data, how closely like an individual pitch track matches the exemplars that were added to the call type originally in the call library. So it's like, how closely does that match kind of the call types there, the calls that you put into that call library. So it's a unitless number. The lower the Mahalanobis distance, the closer the fit. So that means like if you have a pitch track of a right whale up call and it has a Mahalanobis distance of like 1.5, that means it's a pretty close match to the example calls that were in one of the right whale call types that was added to your call library. So it can be used, we use it as a threshold. This is probably one of the most important settings that you can use in your analysis, because it's going to create a threshold that determines kind of your false versus like how many detections you're going to have to go through. Because if you raise this number, it's going to output, like when you do the browse auto detections to actually browse through your data, if you put in a higher number, you're going to get more, it's going to be less picky. It's going to show you more pitch tracks that maybe are further and further away from those example call types that were in your call library. So we have determined, Jen did a lot of testing with this originally with her PhD project. And for most baleen whales, we use a Mahalanobis distance filter of 3. And we found that that's a pretty good setting. It captures most of the true calls, the true detections, and it reduces the number of false detections that you're going to get. So you're not going to be wading through every single pitch track that was generated that it thinks is a right whale, because those don't always, aren't always accurate. Blue whales, I think we're now using Mahalanobis distance filter of 6, but most baleens we use 3. So for this example, when you're exporting your summary auto detections, if you put a 3 here, it's only going to include the number of auto detections for each call type that have a Mahalanobis distance of 3 or less. Which for us, those are the only ones we're looking at anyways. So that's, we put that in here. When you put a number in here, this will automatically change to enable. I think originally when you open this, it says disable, but you just type a number in and it'll change automatically. So after all that, we have all of our settings. I'm going to save it so I don't go crazy in case this doesn't work, and click OK. It'll give you this little readout. And once it hits 100%, you know that it's done producing your file. And look at that. This is the one I did yesterday. Don't pay attention to that. That's the new one plopped onto my desktop that we want to look at now. Momentarily. Okay. So once you have processed your auto detection summary, it'll output your CSV file. These top rows are a mix of some of the metadata that was put into your original parameter file when you process the data set. So you'll see some of this looks familiar to the parameter file that we looked at earlier. And then these rows here are kind of your legend or your key for your column headers down here, right? So column 1, start date, column 2, start time. So it just outputs that. There are the column headers for the different call types. So you can see our different right whale call types, 5, 6, 7, 8, and 9. And it does output the description description of the call types in the next column there. So it gives you a little more information on what you actually output. So we chose daily bins, and we only have a 3-hour data set. So of course we only have 1 row. We can also do this a different way to show another example. So if we want to do, where am I here? So I click restore, saved all my settings from last time, but this time I want to look at hourly presence. So if I change that, run it again. Actually, I wonder if it overrides this file now, because I didn't change the name of it. Yes, it did. That's a good note. If you want to reprocess it, make sure you change your file pathway or name if you don't want it to overwrite your original file. So here now, since we did hourly bins, we get 1 row per hour. And of course, it's only a few hours long. So your auto detections are just in these top 3 rows. So you can see these are the summary columns. So however many auto detections LFDCS classified as call type 5 for that hour, or call type 6 for that hour. And then the sum at the end is the total for that hour of all the call types together. So a quick example of how we use this as a data sheet. This is our NEFSC baleen whale analysis training Google Drive. And I can share this. I think some of you already have access to this, but I can share it at the end of the training. Somebody remind me. But this is what we share with new analysts, and we have anyone who we hire with the passive acoustics branch, we take them through this Google Drive. So I'll explain a bit more of this in a bit, but for this example here, I just want to show our example data sheets. So what we do once we have our auto detection summary sheet exported is we manually copy and paste in a few extra column headers to be able to track our analyses. So we have a manual review column. This is where we give it a manual review score for that day or hour. So if the hour gets a 0, that means they weren't present. If it gets a 1, that means they were. And if it gets a 2, that means they were possibly detected. True tally, that's how many pitch tracks or detections we used to determine our manual review score. So we have a fairly conservative protocol where we require 3 upcalls, 3 true pitch tracked upcalls to say that right whales were present for that day or hour, whatever your time bins are. We put the timestamps for each of those upcalls or detections. Any unknown timestamps, we put in this column. A few of our species, we have just this extra suggested daily presence. This is like if you have a couple of really good upcalls, but you don't have a third to say, give it a score of 1 for the day and present, but you're like, they're there. These are high quality calls. They're loud. We do have this suggested daily presence. This is also like if you have like 2 pitch tracked upcalls, but maybe you see a third that isn't. It actually probably is pitch tracked. It's just your Mahalanobis distance is probably filtering out. Maybe the pitch track doesn't match as closely to your exemplar calls. So if you have we call that undetected though, if it's not pitch tracked with the Mahalanobis distance setting that we're using. So you can make a note of that. Kind of that's just we don't actually use this for anything at this point. We're still just counting we're really just tracking the days where they're definitely present based on our protocol. But this is just an example. So we just copy and paste these column headers into our CSV sheet and save this with our, whatever the deployment name is. And this is what we use for our data sheet, and we fill that in from there. One other thing that you can do. Yes, question.
Yes. Can you please come back to the Excel sheet that you just showed us? The data sheet.
Jen, did you catch? It was just very faint.
Julie, just go back to the training Google sheet.
Yes,
the training one. Yep, with the example columns.
Yeah. So do I understand right that in row number 2 you have total number of calls that was detected 44, but then after when you review these calls, actually you got 0. None of these calls were actually calls, or what does it mean?
Yeah, that's a great question. So that's just so not all of the calls are going to be true detections, right? So that's just like any detector is going to create false detections, or they might be unknowns, like if they're a little faint or something like that. So yeah, you might have like 44 auto detections for that day or hour, but when you actually look through them manually, none of them were actually good enough or clear enough to say they were true detections. So in that case, yes, that day would get a 0. These are pretty realistic numbers for right whales. So it's actually fairly reasonable as far as like how many detections you actually have to browse through for a data set. Humpbacks are a little bit higher, but yeah, in general. And these also you can reduce this number by lowering your Mahalanobis distance filter as well. If you just have, if you're trying to do humpbacks and there's just a lot of false detections or something, if it's picking up a lot, maybe you have a noisy data set and it's picking up a lot of false detections or something like that. So yeah, these are just your raw auto detections from the LFDCS. And then this is a product of the actual manual analysis. Jen, did you have something to?
I guess just so this is our protocol of how we use our call library for our data set, it might be different depending on where you're recording, what species you're looking at. As Julianne said, the numbers are different per species. So like for sei whales, for example, the downsweep call types work really well, at least in most regions. And the number of detections is really low typically to go through. But we found you do need to go through manually detections because it is so variable depending on where you are and what call types you're looking at. And so the numbers can be very different with true or false detections in there. And so doing that manual review is really essential if your goal is to be reporting, who's actually detected and not.
Yeah,
Yeah.
thanks, Jen. It can, yeah, definitely. Like if you have a noisier data set, sometimes you're going to get more false detections. Like the pitch tracks, it'll try and pick up, some of the noise occasionally. And it can, you can have different protocols too. Like for fin whales, we do hourly presence for fin whales, and Jen did an analysis assessing like how many auto detections do we actually want in a given hour that make it, that mean that fin whales are actually likely there. And we got the number 29 out of that. So for our fin whale analysis, we actually only look at hours that have at least 29 auto detections, because we know that that means it's more likely that some of those auto detections or pitch tracks are actual fin whale 20 hertz pulses. So like, for example, this hour only had 18 auto detections, so we don't worry about checking that hour. But these other ones we do have above 29, so we'll check through those and determine if those are actual real fin pulses, which LFDCS is pretty good with fin whales because they're very consistent. Yes, Mark, go ahead.
I was just going to say what Julianne is describing right now is the protocol that that Northeast Fisheries Science Center uses to evaluate daily presence. It may be that your application for the LFDCS, you don't want to do daily presence. You want to do call rates, or you want to do hourly presence. Everything, the detector does its detecting, and then it's up to you to sort of deal with the output in a way that's consistent with your goals for your analysis. Not everyone wants to look at daily presence. So Northeast Fisheries Science Center has done a phenomenal job of laying out a protocol if you are interested in daily presence, where they've like really researched how to do this, do that type of analysis, and they have a protocol for it. And so if you're interested in daily analysis, just use what they used. And then you can refer back to Jen's papers in your own publications, and it's consistent across the board. But if you don't want to do that, that's fine too. But you have to sort of do the work to figure out, okay, well, what Mahalanobis distance should I use? What is there's a lot of things that go into sort of the design of the not the LFDCS sort of parameter file necessarily, but certainly Mahalanobis distance has a lot to do with your analysis goals. And so we can help you think through those things, but I just want to emphasize that what you do with these detections has everything to do with your study design and your analysis goals.
Thanks, Mark. Yeah, it's very much an example. Courtney, go ahead.
This might be a naive question, but I would like to hear your guys' opinion on it. Do you think it's acceptable to use similar methods for data collected from different platforms or different regions, like West Coast glider data? Is it acceptable to use similar methods compared to your guys' East Coast moored data? Or would there need to be more thought going into that process to making those decisions?
Certainly, there
that's
needs
a great
to.
question. Oh, go ahead.
Go ahead, Julian.
I was just gonna say, it just kind of, I think it just depends. Like, we've had people working in, like, we have a colleague in our branch right now who's creating a new call library for for baleen whales off the coast of Australia. Susan Parks has, I think, created a new one for southern right whales. So there's different ways. Like, yeah, if you're working in an entirely different region, you're going to have a new call library probably anyway, which you'd probably want to do some kind of assessment at the beginning, looking at your raw data first, and then comparing, what are your detections looking like. And then you can look at, you can change your Mahalanobis distance settings and see, how many are you actually missing. So it might, yeah, if you're looking in a totally different place, you might want to do a little more looking around to see what it's actually picking up and how well it's doing with the call library that you have created. Yeah, Mark, did you have?
Yeah, totally agree with what Julianne is saying. And the nice thing is, at least one of the things that I found sort of surprising and nice about the LFDCS is developing new call types is not that difficult. It could take you a day or two to identify maybe a couple of hundred exemplars in a couple of different data sets, and bingo, you've got a call type that could work really well for you. Certainly moving over very long distances, like from the East Coast to the West Coast, yes, it probably is best that you build a call library from your local data. But people are doing that already, right? There's already a call library for the West Coast that's been developed with more DMON data. So the type of platform, does that really matter? Do we care that we're using detections from a glider and have built so? For instance, that GOM9 library is derived from my original GOM7 library. All the right whale calls came from glider data, and yet we use that same call type on moored acoustic archival data, from moored DMON data, from real-time buoys, and from gliders. Because on the East Coast, a right whale call is a right whale call is a right whale call. Whether you recorded it on a glider versus a buoy doesn't really matter. And so I don't necessarily think that the platform matters. The platform matters certainly when you go to apply those call libraries, and you may have different noise issues to deal with on each one of those platforms. But the actual detection of the tonal call itself shouldn't matter from platform to platform.
Yeah, and just to even expand on that, so Susan Parks's lab, Sarah Tennant in the lab is working on creating a call library from tag data. And then, we're looking at, well, how is that going to be applied on other platforms? And the answer is it really shouldn't matter, because like Mark said, the call is the call. It's just how it's then applied. And we have a lot of protocols of how between Mark and our lab have looked at evaluating things. So if anyone's interested in that or wants to talk through that, we're happy to help with that, because we have some tips to start with, at least, to evaluate how that goes. But
Yeah,
you.
yeah, Courtney, good question. When you're looking at if you have a particularly noisy platform too, like we've had people ask about this in the past, where if you have a recurring noise that's happening on your platform that is pretty consistent and looks the same most of the time, you can actually create a call type or call types where you pick pitch tracks of that noise out of your data set. And that way you can kind of just filter those out, where you just don't select those call type numbers of the noise. So for example, like the old Marus had this hard drive noise where it would record the hard drive spin up, and it created the same noise every single time, and it got pitch tracked. And I think there was a portion of it that looked kind of like an up call, like there was a little upsweeping portion. And so we actually went through and picked out some pitch tracks. You usually pick anywhere from like 50 to 200 example pitch tracks to create a call type. And we picked a few of those out to create a call type for that hard drive noise. And that way we could try and filter that out, because it works better, obviously, if you have like a really consistent noise. If it's just, random noise, it's a little trickier. You can't really do the same thing with it. But yeah, that's another thing you can do if it's platform specific.
One last thing I'll say, Julianne, is that if you're if you're interested in other call types for animals in your region and you haven't built a call library, if someone has, the whole point of the part of the point of the LFDCS is that these call libraries are shareable. That you should be able to just be able to hand your call libraries over to someone else and they can run with it. Just like Jen and Julianne are handing over the GOM9 library, they put all the work into it, and you can just run with it. So if someone in your area is already building a call library, call them up, send them an email, collaborate.
Yeah, the LFDCS users listserv is a great tool for that too. So if you are thinking of adding a new species or looking at a new region, you can kind of send an email out to the listserv and see if anyone else has worked on that, or share if you have created a new one, just announcing to the group if you've, tested it. Like our colleagues up at DFO in Canada, they created a call library for audible blue whale calls that was separate from the one that we had. So, they shared it with us. Now we have an audible blue whale call library that they've already tested out, at least up in their region. So there's a lot of flexibility and sharing potential there. Leah, go ahead.
So many questions. I have so many questions. Okay. For one, as someone who's like kind of new to this community, is there an online platform of previous conversations or questions?
I would say Julianne's put a lot of the troubleshooting things in the reference guide. So
Okay.
there's some stuff there, and then a lot that's in the reference guide has stemmed from things we figured out in questions.
Okay.
But not an archive of like email questions. That's in our inbox, which I wouldn't recommend.
Yeah, it is kind of
That's
a daunting thing to send an email to a list of people you're not quite sure who's on the other end.
Yeah, most of the common ones we've gotten have
Okay.
been incorporated. So it's definitely I would read through the appendix, the intro, and definitely read through in depth any of the sections of the programs that you're going to use, because there are a lot of like tips, tricks, examples, things like that in there
Cool.
that could help.
And watch the YouTube videos.
Yeah. Okay.
Yeah. Those, yep.
We're not joking. We're not joking at all.
Yeah. Okay, so then somewhere I could find outside of the reference guide information about, like, if you have duty cycle data, is there a way in the parameters to identify that? There is.
You don't need to.
Okay.
It should, well, it depends on how your data is formatted, but it should deal with the duty cycle just fine.
Okay, I'm just like testing something right now, and it's giving me lots of messages saying it's quite large. It's 15 minutes, but I'm wondering if that's like, this is a weedy question. I promise my third question's not weedy, but is that, something that's just what it's going to say if you have a 15-minute duty cycle, or was there a way to kind of prep it for that?
Well, when you duty cycle, you have to think carefully about duty cycling. And I know it's required in many instances when you don't have enough memory. But one of the things that LFDCS does to deal with noise is it uses the past couple of minutes of background noise to help condition spectrograms to be able to pick out calls. When you duty cycle, and there's a large gap between the recording sessions, the first minute or two of every duty cycled recording, the LFDCS is a bit lost because it doesn't have an estimate of what the background noise is, because the recorder wasn't on to give you that.
Okay.
And so that can cause issues that you have to sort of be ready for.
Yep.
So I don't know what you're looking at, Leah. You can send that to me, and I can help you.
We can get a little bit more weedy. I guess in that I'm wondering, I'm just thinking about a lot of things about that, and I'm wondering where I go to look for that, but maybe it's just for more info, and maybe it's just Mark.
Yeah, that stuff's not really written down.
Okay. And then is there a library of call libraries somewhere? with like that describes what they do? Or no?
There's
Okay.
the 3 that we gave, which is the broadband,
Yep.
which you don't need to, that's just placeholder. The GOM9 is, it has most of the baleen species. And then the low frequency blue is the one that we actually use for blue and fin whales. I will show toward the end when I go through call library stuff, there's a way that you can open up a list of the call types that are in each call library that
Okay,
have the
cool.
descriptions that people,
Yeah.
you can
Okay.
look up.
Great. Thank you.
Good questions. Okay.
And one quick correction, Julianne said that DFO did that audible call library. That was actually University of New Brunswick. That's Kim Davies' group. Just wanted to
Thanks.
throw that in there.
Sorry.
No.
Okay.
And then one just quick thought, Leah, when it says it has a high files, like it's a really big file, just make sure you resample the data in your parameter file. Sometimes if you're trying to process a data set that's a high sample rate and it's taking a really long time, sometimes the parameter, I've forgotten to resample the data in the parameter file down to 2 kilohertz, and that will cause it to be really, really slow.
Yeah, that's
Yeah,
okay.
Leah, we should talk. You're taking sound trap data that's recorded at very high frequencies, and you're getting it down to sort of the baleen whale band, right?
Yeah.
Let's talk about that. We've learned some things in the last 6 months about that process that
Okay.
and if anyone else we'll figure out what's going on with you, but we'll put an email out on the LFDCS listserv to explain best practices for that particular application.
And I guess like I'm playing around with data that was recorded at 96 kilohertz, but the data that we're recording here as part of this project that's relevant to this training is 48. And so that's just, we don't have to get into the weeds right that, but I'm just saying right now that I got it.
You still have to so our call libraries are for 2 kilohertz sample rate data. So everything you have, you'll want to resample for our GOM9 call library. And then that low frequency one, you want to resample again. So just for everybody to keep in mind, because we're now sampling a lot higher in most of our data sets. And when we started, we really were mostly working with lower frequency to begin with. And so in those test parameter files that Julianne showed, just double check and make sure there's a resample rate in that one that you're copying to make sure it's there.
Okay, so I was sorry to monopolize so much of this, but I was looking at that test param soundtrap LF from raw audio, and I guess that's the issue, is I should have been using the 2 kilohertz. I got it. Thanks.
Welcome to LFDCS. There's lots of knobs and things to pay attention to, but that's the case with any detector.
Okay. Real quick before we take a quick 5-minute break, I just wanted to, because we've gotten this question in the past, there's one other program for exporting, well, there's a couple, I'm not going to show this one, but it is explained in the reference guide, but this export auto detections program, if you have gone through and analyzed your data and maybe scored calls as either certain call types or certain species, or you've gone through and, labeled calls as correct or incorrect or unknown or whatever through your analysis, and you want to export a sheet that just has a summary of all those scores, you can use this export auto detections program. I already put in all my settings in here. You just direct it to your LFDCS file index that's in your LFDCS folder. You give it a name, make sure you put CSV at the end. And when it outputs, it will look like this. So similar, you got your metadata, you have your column header key, and then there's this column here that says manual species code. And when you run this program to actually get that column, you do need to make sure that your this field export manual detections, make sure that this is selected as true. And that way it will generate, that way it'll give you your manual detection scores that you did yourself. And it'll put it into this manual species code column. And this looks like what are these numbers? They are in the reference guide. So here, table 1, I think this is page 71 or something, 55, just kidding, 55. These are the we can go through some of this more when we do like browsing and call library stuff, but this is for your species codes and your call types codes. So certain species, we've actually generated categories that are not species, but we use them as that. So we can do analysis where it's where you have like correct, incorrect, or unknown options for scoring different auto detections. And so we just have these numbers here. Matt can explain how these were generated originally, but these are like, if you want to filter out and only look at the ones you scored as correct, you can, in your summary sheet, you can filter in the column for only showing the ones that are 9999. Unclassified is this -32767 number. Incorrect is -9999. And then unknown is 0. So when we look back here, we can see that these detections here were scored as correct. This one was unknown, and these ones are all unclassified. Either you haven't gotten to them yet or you skipped over them. So this was a good question. Part of our, like, if you're doing something like daily presence where, you're looking through part of the day, maybe you get enough evidence that they're there and you're ready to skip to the next day, and you're leaving a portion that you didn't look at or you left unscored. We've gotten that question in the past where, how do you go back and look at which ones, how much you didn't actually look at? This is one way that you can do that. Or just, get a summary of which ones you scored as correct or unknown or incorrect. Okay.
Can I just flag one more thing on the auto detection sheet? This is where that start date comes into play. So you'll see the start seconds and end seconds column. And in the header information above, it'll tell you what your start date that you set it to is. So if you ever need to find the actual start date and time, you can calculate it using that. So here it's saying in your parameter file, you said the start date was 11060 o'clock. And then you can calculate your actual date for both the start second since and the end second since columns from there.
Perfect. Thanks, Jen. The last program before we get to call libraries that I'm going to go over is the Browse Auto Detections program. So this is once you've processed your data set, you have your data sheet and your summary ready, and you're ready to actually do analysis. This is the program you're going to use. So we can click on our program here. So I'm going to just restore some settings. So this is, again, this LFDCS file index that's from your LFDCS folder of your processed data. You don't, if you're just wanting to start at the beginning of your data set, you do not need to specify a start date. It'll just open to the beginning of your data. This is, however, a nice way to bookmark your, like if you're working through a data set and you want to save where you left off for the day, you could put your start date in here and the timestamp of where you left off in the data set and save it. And that way, the next day when you're ready to start your analysis again, it'll start you off right there when you restore your program settings with your preset. So just a little trick there. We used to save it in our daily code document with version 1, but now it's all in a program window. You'll just have it narrowband call library, not broadband. This is similar to what we looked at before. So this is your call type list. So this is where you'll put whatever call type numbers you're wanting to browse for. So here we have all of our right whale call type numbers 5 through 9. So this means it'll pull up all the pitch tracks that have been classified as any of those right whale up calls for us to browse through. There are various filters that you can use. So if you want to look at pitch tracks that are within a certain amplitude, maybe you want to, filter out fainter sounds or focus on faint sounds. You can also adjust your Mahalanobis distance filter. So this is definitely where it's good to use the Mahalanobis distance. Also, in our previous training videos, there's a part 1 that Mark does a wonderful job of explaining the whole LFDCS algorithm and the background. And he provides a lovely explanation of the Mahalanobis distance that's a little more in depth. So if you're wanting to hear about the nitty gritty of the Mahalanobis distance filter, and all the different variables. We will look at it a little bit when we look at call library stuff. But I just want to highlight that part one video, we're not going to repeat it here because we already have it recorded, but that will stay on the Robots for Whales website. And I'll show that later in a bit where you can find that video. It is actually, I would actually recommend it for anybody who uses LFDCS. It's a great just kind of background, like how are pitch tracks generated? What is the Hal-Nobis distance, all that kind of stuff. So definitely go watch Mark's video before you get into it. So here,
one other thing on that, in terms of like why we've stuck with 3, Mark's paper shows where detections fall and why 3 is a good number depending on your study goal. So just that's a really another thing to highlight if you want to know why we stuck with this number and why it's important or helpful depending on what your purpose is. That's a good thing to look at as well.
Yes, thanks, Jen. So we definitely want to have it set to 3 or whatever your number is, but we recommend 3 for most baleen species because this will mean that you are not looking through a bunch of false detections of pitch tracks that don't even look like your calls, right? This will kind of hone it down to the ones that most closely match those example call types in your call library. So have it set to 3. If you want to have a frequency filter and only look at pitch tracks within a certain frequency range, you're welcome to input some boundaries there. This classify, you want that set to true because that is essentially saying like, yes, you want to generate some buttons in the browsing window that are your classification buttons. So that's just saying like, yes, I want to create those buttons. Your manual species list is where you direct it to whatever buttons you want to display. So this takes us back to that table 1 in the reference guide here. So manual species list. So these numbers here are, there's 4 numbers which correspond to 4 different buttons that we want in our viewing window. This will become clear momentarily when I actually open the viewing window. But again, we have positive 9999, which is the code for correct, which you can find in the table here, right? These numbers down there. And negative 9999, that's the button for incorrect. 0 is unknown, and this negative 32767 is unclassified. So you want to have those in there. You can also put in actual, like if you, rather than wanting to mark things as correct or incorrect, you can put in like examples of, or there is an example, sorry. This is, let's look at. This example here. So this is if you want, rather than creating like correct, incorrect buttons, if you want like species call type buttons, like if you want to label different pitch tracks as different call types. So just kind of a different way of analyzing your data depending on what your goals are. You can put in the species code. So for example here, this is 277, which if we go to the reference guide, 2 is the species code for fin whale, and 7 is the species code for right whale. And then we want to get their call type codes. So down here, this manual call type list, 1, 1, 2. So this is saying each, like this first number corresponds to this first number up here. So this is saying you want to have a button that is for a fin whale, and then number 1 here corresponds to the call type code for the 20 hertz pulse. So this is saying you want to create a button in the viewing window so you can label different pitch tracks as a fin whale 20 hertz pulse call. The next ones are, because we have 7, 7, and then I think I put in, what did I put in, 1 and 2? Yeah, so this is saying this second one is saying you want a button for a right whale up call, and then I think a right whale moan, is that number 2? Thanks, Jen. Yeah. So that's, yeah, call type code number 2. So just a different way to set things up if you want. But for this example that I'm actually going to show when we open the window, we're going to use the correct, incorrect buttons. I'm going to get rid of that. So let's try and.
Courtney has a question before
Oh,
you.
yeah. Go ahead, Courtney.
Sorry. So when you're building out a call library, do you also build out the manual species code list? Like if I wanted to have one for, you have Finwheel 20, but if I wanted to add Finwheel 40 hertz, would that get a new number in the new call library?
Yes. So if you just wanted to add a new call type, you're saying?
Yeah.
Like
They're,
a
s-
20.
they're slightly different. So yes, when you add a call type in your call library, you will assign it a number in your call library, but then those numbers that Julianne was showing in the manual species and then the call type species for the buttons, that's in a separate file. That's that CSV. I believe it's in the process folder. It's called manual calls, manual codes. Julian will find it. So they're kind of two different things. They're not referring to the call library itself. Yes, the manual classes. So that CSV is what LFDCS looks at for the buttons, which are like looked at separately than the call library call type numbers, if that makes sense. But
Yeah.
here,
Okay.
okay, great. So here is where you would add however you want to do that. So you can add your own species code number if it's a new species, or you would repeat the species code number for a new call type of that species, and then create a new call type code for that species code.
Okay. So you would update it here, and also within your call library, you can add the call. Okay. Thank you.
Yeah. Yep.
Yeah, call library programs, you can actually like put in exemplars and create the actual call type. And then yes, the manual classes file is where you can put in the codes that you will use to generate the buttons that you want. Excellent question. I actually forget to share that sometimes. Okay. So once you've added your program settings in and click OK, it'll pull up the Browse Auto Detections window. And you can see over here on the right-hand side, these are your buttons that we programmed in. So we have our correct, incorrect, unknown, and unclassified buttons. When you start analyzing a new data set, all of the detections will default as unclassified, which you can see up here. And it'll give you the date and the timestamp for the pitch track that is selected. The quote unquote selected pitch track will usually center itself in the middle of the spectrogram. And there are a few tips and tricks here. All of this is described in the reference guide. But the black areas on the left and right-hand sides of the spectrogram are essentially like your forward and back buttons. They're just kind of hidden. So if you want to move forward in your data set to see the next pitch track, you can click over here on the right and it'll move it to your next, whatever your next pitch track is in the data set. So as a reminder here, we're only looking at when we put the program settings in, we're only looking at all the right whale up calls, and we're only looking at calls that have a Mahalanobis distance of 3 or less. So that's saying we're like, most of these are probably gonna be pretty good up calls. And so you can click through this way. If you're actually wanting to score things, you just click the button and it'll move it to the next pitch track and score your previous one the way you wanted it. So if you want to double check that, you can click over here on the left. It'll move it back to the previous pitch track and you can see that your score is now changed to correct. And so that's the way that you can move through your data set. All of these are lovely, so we'll say all correct. Probably kind of a mode. Maybe we say unknown for that one, whatever. If you move backwards, you'll see that it's now labeled as unknown. If you make a mistake and you score something that in a way that you didn't want, you just click unclassified. It'll move it to the next pitch track, but you can go back and look, and this one's now redone as unclassified. Everything is auto saving, so it will automatically save to your LFDCS folder that was produced when you processed your data set. So there's no like save button. All of your scores are automatically saved as you go. So we'll just quickly go through the buttons over here. These are also described in the reference guide. So page forward and page backward. This is good if you have like a bunch of up calls in one viewing window and you want to just kind of skip over and move to the next cluster of pitch tracks. I think I said up calls meant pitch tracks. So you keep paging forward that way. Page backwards, same thing. It'll just kind of move to the next cluster rather than if you click in the black area, it's just going from one individual pitch track to the next. Zoom in and zoom out. pretty self-explanatory. I think it starts as zoomed in. Yeah, as zoomed in as you can get. Oh, this is the hard drive noise. Well, actually that could be, anyway.
It's an up call right before.
I know, is it that? Yeah, that's a real up call, but this whole thing is that hard drive noise I was referring to earlier with the Marus. So you can also zoom out and get a better idea of what's happening around. Like if you're analyzing for right whale and you want to like check and see if there's humpbacks on around or something for interference, you can zoom out a little bit.
Julian, can you show in that zoom the page forward, just so like when you page forward, you skip all of those detections in the window and it goes to the next first one, just so everyone's clear.
Yeah, it'll just skip these, like this one. It won't select that one. It'll just skip it and move to the next. Okay, zoom. Ooh, I don't want to keep zooming out. I want to zoom in. Okay, lovely. If you want to jump to a certain section of your data set, you can use the jump button. This is nice because with our protocol, like we need 3 true pitch tracked up calls to say detected for a day for right whales, to say they're present. And so once we get those 3 true up calls, we just jump to the next day. And so we can use this jump button. You'll get this little pop-up window here. So we can say, this is a short data set. So we'll say 3009 and then say maybe in 1 hour. Oh, wait. Like that. And then you can click OK. And it'll move you to whatever the next pitch track is after the timestamp that you entered. So that's the jump button. Volume and speed, you can adjust here. Again, it'll give you a little pop-up window. Volume is set at 1, or they're both set at 1 for just a default. The volume, you can increase pretty substantially. Obviously, be careful. Don't blow out your eardrums and set it to like 500. Like sometimes I'll increase it to, 2 or 3. If it's a really quiet data set, maybe I'll go to 10, but some people use higher numbers if they have really faint data. So feel free to play around with that, but just be careful of your eardrums. And then speed is just like you can increase it to 2 times the speed, 3 times the speed, whatever. So you can adjust that for your playback speed. Click OK, and it'll automatically set it to that. The play button will just play whatever pitch track is selected with a little bit of a buffer on either side. I think it's about a second on either side that it'll play. So you can click that and it'll, it's not going to play over the Zoom, but it'll play a little clip with that selected pitch track included. And then, yes, Mark.
Hey, Julian, just quick note on the speed and volume. So the whole reason there's changes of speed in this is because there are some species that you just can't hear. If it was a blue whale or even a fin whale 20 hertz call, you're not going to be able to hear them through your headphones, and you'll be lucky if you hear them through your computer speakers. If you were in a movie theater with like Dolby sound, sure, you'll be able to hear them, but many of us don't do our audio analysis in a movie theater. So increasing the speed will increase the pitch of the sound and put it into your hearing range. So for example, I like to listen to fin whale 20 hertz pulses at 12 times speed. I like to listen to say whale calls at 6x, and I like to listen to right whale calls at four times. And never listen to any of them at normal speed. Everyone's different. I think that's why Jen's laughing, because her ears are younger than mine, and so maybe she doesn't have to put them up in pitch nearly so much. So it's whatever you choose that's good for you, and then I would say stick with it, because then to me a fin whale 20 hertz pulse train that might last a minute, I can play that very quickly at 12x, and I know I've trained myself to know exactly what a fin whale 20 hertz pulse train sounds like at 12x. So if you constantly changing the speed, you won't get sort of dialed into what that call sounds like. So anyway, that's why there's that speed thing in there.
Thanks, Mark. I kind of brushed over that one. Yeah, it's helpful with determining, like, distinguishing between biological and non-biological sounds sometimes too. Like it can help, like increase the speed for an up call to, 2 or 3, it can, if it's just ends up being like some ship noise or something, like usually you'll be able to tell. You won't get like such a nice up call sound at a higher speed. But that's funny. I don't know where I got 24 times for fin whales, but that's what I listen to fin whales at. And it's actually, they have a nice like doop, 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 doop.
Yep,
And
that works too.
Yeah, it's very personal preference. But there if you need it. Okay, play range here. This is if you want to listen to more than just like, a couple seconds on or a second on either side of your pitch track. So if you click this button, nothing happens. That's because you need to actually go over to the spectrogram and click wherever you want your clip to or range to start, and then clip where you want it to end. And you'll see it doing things in the log window back here. And then it'll play that clip. I believe is there a stop? I thought there was a stop button now. Never mind.
No.
Okay, so the disclaimer still applies. Be careful if you're really zoomed out in your spectrogram and you go to play a range. If you select like a 20-minute range, it's going to play for 20 minutes. I believe there's still no way to do that. Okay, so just
sorry about that. I could never figure out a way to get it out of playing.
I think
it shows you bars now. So if you click play range, it should show you where you start and end the click. So that'll tell you what's playing. So you at least know that you clicked a huge area and you just have to wait for it to stop.
You just go get a cup of coffee.
Exactly. The log window will say, I think audio stop playing when it's done. Oh, finish playing audio. Yeah.
Yeah, I think we've all done that once, and then after that we never do it again. It's a quick learning curve. All right, so frequency range. So this is if you want to kind of zoom in on your frequency axis. Maybe you only want to look under 700 hertz, sorry. So that'll zoom you in a little bit. Toggle tracks, that just toggles the pitch tracks on and off. A lot of analysts I know actually do their analysis with the pitch tracks toggled off because they know that whatever selected or detected pitch call is going to be centered in the middle of the spectrogram. So you can kind of keep your eye centered in the middle, but it helps you look because sometimes the pitch tracks kind of, it's hard to see what's underneath them. And so you can toggle them off and flip through the data set this way. And you know that all of these are likely pitch tracked. So you can toggle it on and off that way. If you want to create a clip, kind of similar to play range. So when you click the clip button, you also need to go over here and select the range that you want to clip. And then it'll give you this pop-up window once you've selected that. And it'll give you an option to save at the normal volume and speed or the currently selected volume and speed. So if you select normal, it'll save it at volume of 1 and speed of 1. If you click selected, if you have adjusted your volume to say 10 and your speed to 5, it'll save the clip with those settings. So I don't think I even changed them here. So we'll just go to normal. You're going to name your WAV file. I believe this is one of those cases. It's not labeled, but you do want to include the extension, the file extension in your name. And then similar situation as the auto detection summaries. If you don't select where you want it to output to, it will automatically get plopped into your process folder here. So this guy. So when in doubt, go to your process folder and look for it. Otherwise, we can select, we'll just put it on the desktop, save, lovely, okay. Yes, it says it did it, good. And there's our test clip. Autoplay is where it'll automatically play the selected pitch track with a second or two on either side as you click through them. So if you want to listen to every single one and you want to listen, you can just click that and it'll do it. And then auto class, you can click that and it gives you a little bit of additional information about the selected pitch track up at the top of the screen. So for example, like this one this was classified as call type 8, which is a shorter upsweep. It's a fainter call, so I think probably just the base of it got pitch tracked there. It has a Mahalanobis distance of 1.6 and a probability. I think this is the probability of it matching the exemplar call type.
It's probability, the posterior probability of group inclusion, and you can watch the video to understand that in Mahalanobis distance much better. So I won't explain it here.
Good, me neither. Okay. All right. So those are your buttons. There's not much else you can do to edit your spectrogram settings. That's things that you would do to mess around in your parameter file, but it's pretty good. Like, especially if you process with the low frequency parameter file for like fin and blue whales, you'll get a better image with the lower frequency stuff. So this is, and it is pretty decent. Like all of our analysts use this setting and it works pretty well. We got some nice fin whale pulses down here and maybe some humpback. Okay. Any burning questions about the browse auto detection?
Can I
Yes.
interject real quick? Two other fun facts for scrolling is you can actually use your mouse scroll to go forward and backwards, and that can be both on the spectrogram image itself. You can use the scroll over buttons like Julianne's doing now. So if you have if you're going through most likely a ton of incorrects in a row, you can scroll on the incorrect button too. And so that's as you're going forward, it'll automatically mark them. And same for the page forward. So for humpback whales, for example, we'll just go through pages at a time. And so you can just page forward rather than having to mark every single call or detection. So just, yeah, as you go different ways, you can browse and quickly browse.
Yeah, I think it's definitely helpful for preventing carpal tunnel. I didn't learn that one until partway through my first, I think, year of analysis, and it was nice to know that you could just scroll through. I might have mentioned this, Jen. To just be careful if you are just hovering and scrolling. There can be times if you're staring at the spectrogram, your cursor can drift off the button or it can drift onto a different button. And then you could be scrolling for 10 minutes and then realize that you've misclassified a bunch of them because your cursor drifted. So ask me how I know. Don't do that.
That's a really good point. And I was going to say that's why. So a lot of people have asked, why do you need to mark things in the summary detection sheet that we do rather than just use the auto detection export? You totally can. From our experience, you can easily drift off the button. And so things aren't always marked maybe as you hope. And so for us, we use that summary detections auto sheet to add more information and also make sure we really capture everything, but you are certainly able to do it from the auto detection export and write code to summarize things yourself too. So.
All right, so really briefly, I'm just going to go through a few additional resources, and then we'll probably just jump right into the call library stuff, and we'll do Q&A at the end. So a few things. On the Robots for Whales website, I pulled it up, but I'm going to just navigate it from the main page as someone would going to the web page. This beautifully redone main page for the Robots for Whales website, we should all appreciate because Mark worked on that and it's lovely. If you go to the About menu, go down to Resources, it will give you, eventually this will link, it's currently an old draft or old version, but this will eventually link to the LFDCS 2.0 reference guide. And then under training videos, we have some old training videos from the DCLDE conference back in 2022. We now have some updated training videos from June 2024 from the last DCLDE conference that we recorded. Some of these will stay up, but this recording of this training we'll probably label these as like version 1. And then this recording that we're making today of this training will also be posted to this website eventually as well. So a couple things here. The LFDCS introduction, Mark does a really nice job of going through. This is the video that I recommend pretty much everybody who uses LFDCS to watch, because he really goes through the whole algorithm and how it works and Mahalanobis distance and all that stuff. Also, the LFDCS applications video, Jen goes through kind of how we've used the program in various ways over the years. And so that's a helpful one too if you're, trying to think through project design. If you're using the old version and want to refer to these videos, these go through the code and all that. These are, in the meantime, while we're waiting to get today's video posted online, these really do walk you through the programs in the same way that we did today. It's just going to show you how we used to open them with the code rather than with the GUI. So these videos, or at least, sorry, this one is still very applicable. And then, of course, the real-time stuff at the end. So lots of good resources there. What else do I want to? Our Google Drive, which if you would like access to our training Google Drive, this is the Northeast Fisheries Science Center baleen whale analysis Google Drive that we've created. And we share with whoever really wants to just, see our protocols and model, if you want to use a similar protocol, you're welcome to do that. But these have the introduction slides are more applicable to folks who we hire into the acoustics branch, so might not be quite as useful. There's a couple of slides that have some animal recordings and stuff like that and spectrograms, which are nice to look at. We have a literature folder here, organized by species. There's also the original LFDCS, Mark's LFDCS paper, and Jen's multi-species migratory corridor paper. So some important resources there for baleen whales. We've also created quick guides based on that literature. So you also can go here to access quick guides for all of the baleen whales that we analyze for. So there's a note up at the top about which call types we actually use at NEFSC to do our analysis, but then there's some general information about the species and the call types that they produce. Some region information. You can always go to the Passive Acoustic Cetacean Map or PACM website to look up, the latest on where they've been. I think that's going to be updated pretty soon. And then just some general information from the literature. So just kind of a summarized version of what kind of calls each animal produces. And we also, most of them have examples of screenshots that our analysts have taken directly from LFDCS. Some of them also include kind of caveats that are good to know. So if you're doing analysis for right whales, most of you also know that humpbacks produce upcalls of various types as well. So we have some screenshots of what it can look like when upcalls are in pattern, and how to distinguish them from humpback if you can. Sometimes you can't, but the quick guides are there. There's some Raven training stuff if you're interested. The baleen whale training data set. This is, I would recommend for anybody who is new to acoustic analysis in general, or maybe you've only done, right whales and humpbacks and you're wanting to do some say whale analysis for the first time. There's a whole training data set with sound files and Raven call logs that you can download and access for each of the species there, or just example clips. So if you want to just go in and browse what we know are correct examples of those species, those are there. The LFDCS reference guide and training videos are linked here. You can also just go to the Robots for Whales website. And then this is our daily presence analysis protocol guide, daily code examples. If you're still using version 1 and you want some code examples for different species and programs, you can access that. This is our daily presence sheet guide, which we looked at earlier for each of the different species, how we fill out our analysis sheets. And this is our protocol document for our presence analysis for all of our baleen whale species that we do it for, aside from minkies, I think. So scrolling down, this is just if anyone wants to look at like what is our criteria for scoring daily presence for say whales or right whales or fin whales or whatever. We do hourly for fins. So I'm not going to really go too much in depth aside from just saying like we do include our settings that we use for each species. So for example, right whales, you can tell here that we use a Mahalanobis distance of 3 or less for looking at right whales and processing data for right whales, or just browsing for them. So you can just get some information there. So if you want access to this Google Drive, just email us and we can grant you access so you can look through any of these resources. And then the last ones I'll talk about are just the NOAA Sounds in the Ocean web pages. There's 3, one for mammals, one for environmental and anthropogenic sounds, and one for fish and invertebrates. So these are just great resources. Each one has a spectrogram that you can click on to see the calls. Those are 20 hertz fin whale pulses with the blue whale calls underneath them. And there are clips that you can download that are actually already adjusted for speed for some species. So like, for example, fin whales, the clip is at 5 times. So just keeping that in mind. So lots of examples here. If you're just looking to, dig into a new species to analyze and you just want to look at some correct examples of calls. And then DOSITS is also the discovery of sound in the sea. That's also a great resource for, they have a whole gallery. They have webinars for acoustics and other things. But they have a whole audio gallery that you can go in, and they actually have great written descriptions for characteristics of different species and stuff like that. So just some good general resources to be aware of. I think that is everything, and we are ready to jump into call library things. Yes, Courtney.
Is your Google Drive linked to your lab manual at all?
I believe we're going to put it all on there, but not yet, I think is the correct answer. But that's a great point, Courtney. But yeah, no,
that was more just for my future reference, but thank you.
Yeah, no, definitely the goal. Yeah.
Yeah, I think, some of the general information, like we have like species examples and stuff on the lab, like in the lab manual. That's also another good resource that I can send the link to folks after. If you just email us, one of us, and we'll get you links to things and access to things. I don't think we have it linked on there currently, but maybe in the future. You'll still need to request access anyways because it's Google Drive, but yes. Good question that I didn't know. All right. Okay.
Can I suggest, in case anyone doesn't want to stick on for the call library things, if you're all set with that, if anyone has questions beforehand, feel free to ask first, and then you can hop off if you're done.
Any questions for anything we've covered so far? Plow through. This is good though. Okay. Also feel free to interrupt me as I go. Okay, so we're gonna go through 3 call library programs that you can use. This is really only applicable if you are either going to create a new call library. So kind of related to Courtney's question from earlier, where like if you're in a totally different region with different species, obviously you're probably going to need to create a different call library if one doesn't already exist for that area and those species. So either creating a new one or adding more example call types to call types, or example calls to call types, or if you're wanting to add actual like whole new call types to an existing call library. So we'll cover all of that. So three different programs here. The first is this call library create new. And again, all of this is described in the reference guide as well. So when you want to create a new call library, there is one step that you do need to take prior to running the program, which is somewhere. It can be in the distribution file or elsewhere. You do need to create a folder for your call library. So here, this is where I've set up a call library narrowband test folder. Yes, now will this 2.0 work with IDL? Oh, that's do we know if it will work with IDL 8.7? Sorry, I was reading the chat. If version 2 will work with IDL 8.7?
We haven't tested it fully, so it's worth trying.
Yeah.
And seeing, and if you get an error, that might be the reason, but I think it should be okay. But it was written in IDL 9, so there's a concern that there might be some things that won't work.
Yeah. I think somebody's tried it with, isn't there a 9.1 now too? That, yeah.
It should be fine for
Um,
future, but you can also go back and get an older ideal license, but I think 9.0 is really what we would recommend to ensure everything's working. But 8.7 might work.
Worth a try, probably. Okay, so yeah, so for creating a new call library, you just need to have a folder, just an empty folder with the name of your call library. And oh no. Okay. So once you have your folder, you're gonna click on the create new program. And the only thing here that is required is for you to select where that folder is. So we'll go distribution file, supplemental, call library, CLNB test. And you'll want to have a file name. I think they're just named whatever the call it. Yeah, so call library GOM9. So this will be call library test. So we'll select that folder and then we'll say call library test. Don't forget the extension there. It'll give you a little reminder to put that in. Save. So that'll populate there. I'm gonna save it just for kicks. Okay. It'll prompt you to enter a unique description of your call library. So you could say, right whale call library, or, Australia Marine Parks, whatever your, region is, whatever. This, we'll just say test. Is this call library for narrowband calls? Yes, always click yes. And voila, it is successfully created. And you'll see now that there are your call library files that have populated your empty folder. Done. You have your new call library ready to go. What do you do with that call library once you've created it? You're gonna want to add exemplars or example calls to create your first call type. So to do that, you're going to use the Find Exemplars program. And it's going to open up this window. You're going to select your LFDCS file index. I'll just do this manually just to show it. So we'll just use the test.
And this is obvious because Julian's showing you, but so you have to have data processed with LFDCS because it's using pitch tracks from there to build the call library, not raw audio. So if you have a data set where there's the calls that you want, you would process that with LFDCS first. It's fine whatever call library you use in the initial processing because building the exemplars won't have an effect on what call library you use.
Thank you, Jen. That's just a good reminder. Also, I did forget to mention, if you want to, where is it? Isn't that we have a program for, the review manual detections. If you just want to, if you haven't, you can use this is like without processing your data first, right? You can just manually browse your data, or do you need it? Oh.
It's still going through spec audio. So
Okay.
The manual detections program is if you don't want to go through auto detections and you want to, like Raven, go through, minute by minute and log things, you can use the manual detections program for that. But every program needs to be processed and needs a spec audio folder. Because LFDCS works off the spec audio. So it's not using your raw data, it's using the processed version.
Yeah. Okay. That makes more sense. And the manual detections, it just, you won't be looking at the pitch tracks, but you'll be looking at the spec audio that was generated. Okay. So back to the Find Exemplars, this select call library, you're going to want to select that call library file. So go to wherever you created that new call library folder. And you're going to select the base file that doesn't have any of the suffix there. You can do a start date if you want to. If you have like a certain place in your data set that you want to look at that have like a good chunk of calls, that's good. We do recommend, so when you create, you can have multiple call types within a call library. So for example, like we have our 5 different right whale call types, right? 5 through 9. For a single call type, say like a short up call or whatever, you do want somewhere between 50 to 200 exemplars, and we do or example calls that you're going to add to that call type. We do recommend looking over multiple data sets if you have them, and collecting some exemplars from different data sets. Add some ones that are maybe not as high quality, to just put some variety in there, because you don't want to tailor your call type to just like perfect up calls. You want to have some realistic variation in there a little bit. And we'll show in the next call library where you actually go in and evaluate how your call library is working. It'll show when you add a bunch of exemplars, if some of them are kind of branching off and look a little different than some of the other exemplars, it'll kind of show that in the display, and you're able to split those into actually 2 different call types in that case. But that's just some tips and tricks.
And on that note, so you want to get a variety in terms of like different animals, different individuals who are making that call, but the pitch tracks themselves, you want to make sure they're good pitch tracks that capture the call. So if they're faint, that's great, but the pitch track should look like the call, because if you're getting, sometimes calls are not pitch tracked perfectly, and so if you add pitch tracks that are abnormal in there, then you're going to get not bit more junk. And so you want to have the pitch tracks look relatively similar. And as Julianne said, then you can also look after if you're getting really kind of 2 call types within one, we can look at how you assess that, and then you can break that off further. And there's we have lots of tips going forward if that's something you're interested in. So just to mention that.
Yeah, we're definitely happy to do a meeting or whatever, like if you're just wanting to work through how to create a new call library and talk through some things. We're happy to do that. Okay. I think, yeah. So start date, if you want to like navigate to a certain spot in your data set, great. Call type list. This is if you have existing call types in your call library that you want to pull up to add exemplars to. And you're same with the call type buttons list. Yeah, Jen.
So I believe the call type list is going to show you pitch tracks that most resemble the call types that you list. So if you're interested in adding exemplars to an existing call type, that would show you mainly pitch tracks that would be classified as that call type as you go. The call type buttons list will be what buttons are given on your window, like the correct, incorrect buttons that pop up, so that when you have a pitch track, you can select that call type. And so that call type buttons list is important when you have a call library that has like 20 call types. You want to specify which buttons you want, because otherwise it'll just show the first like 7 or 6 that fit in the window. So that's where you can specify which ones you're adding to.
Yes, and this is all included in the reference guide as well. You can tell I'm already forgetting things. So page 16. So it will go through, this is creating your call library, put your template folder in. This is the Find Exemplars program. So I should have explained this earlier, actually. In the reference guide, it'll usually show an image of the program window. And then below it will provide definitions for what each of these fields is or are. So actually we might want to, I'm going to make a note for the call type list, because I think that could be explained.
I think that's correct. Yeah.
Is it? Yeah, just enter, that you want to browse for if you have existing call types in your library.
Yeah, it'll kind of hone in on pitch tracks that are closely resembling what you've built. But I personally probably wouldn't use that, because you really want to add exemplars that you probably don't have yet, and so that's not as relevant depending on what you're doing.
Yeah, this is why there's that section about minimum frequency, maximum frequency. It's just like give me all the pitch tracks in this band, and then you get to go through and figure out which one you want as exemplars. And then using the Hall Novus distance or the call types really gets into refining the call library more so than picking your initial set of exemplars.
Yeah, the frequency one would be nice. Yeah, like if you're just wanting to look for right whale up calls, you might set it from like 0 to 400 or something. That might even be a little high, but that way you won't have to worry about looking at pitch tracks that are higher than that. Okay, I think so. I'm gonna leave these settings blank for now, and we're just gonna open up the find exemplars window to be able to create a new call type. So I'm gonna click OK. It's gonna give you this little thing that says there's no call types in the call library. Start by adding a call type. Thank you. Yes. And then it's going to open up this window here. So similar, I didn't add any buttons. Oh, that's because we didn't have them yet. Okay. The buttons here are, at least most of these are very similar to what the Browse Auto Detections program has. So page forward, page backwards, we'll skip clusters of pitch tracks and skip to the next one. You can see here, like here's the hard drive noise, like all these pitch tracks up here. This is where, you know, if you want to put in the frequency filter and just not have a bunch of pitch tracks up at the top and just show ones down here, you can do that, or vice versa. Zoom in and zoom out, same thing. Jump, if you want to jump to a different section of your data set, volume and speed, same thing as the Browse Auto Detections program. Your audio filter off is, I always forget.
I forget too. I think it's in the reference guide though. Clearly
It's
we
in the
don't use it often. So
when in doubt, here we can actually use our own resources. Audio filter off. Apply as a band. Oh yes, band pass filter to filter out the background noise above and below the selected pitch track. So if it's on, you'll only be listening to that frequency range that the pitch track is in every time. Okay. And then it'll play a little buffer on either side, but it'll just play the selected pitch track. Play range, same thing. When you click that, you're going to want to click on either, like wherever you want your start of your play period to start, and click where you want it to end. Frequency range, this is if you want to adjust your viewing window. So if you want to zoom in to a different frequency. Ooh. Oh, there it goes. Just took a minute. And then hide pitch tracks. So if you just want to, look at, just get a clearer image of what the sound is underneath, you can toggle the pitch tracks on and off. Compare audio. If you click that, it'll play your selected pitch track. It'll play that clip, and then it'll play the clip of the exemplar call types that are in the call. If you have an existing call type with exemplars added, it will play your selected one, and then it'll play the first exemplar, like clip of the first exemplar that was added to that call library, and then the second one, and then the third one. So it'll essentially provide you with an audio comparison of your selected call or sound with the existing example calls that were already added to that call type. So you wouldn't use this compare audio button if you're creating a brand new call type, because you wouldn't have exemplars in there yet to listen to. But it provides you with an audio comparison. And if you are creating a brand new call type or call library, this is the most important button, because you're going to want to add a new call type. You're going to want to create your first call type. Yes, we're sure we want to add one. If you go up here, enter call type, this is where you assign your call type number, right? Yeah, call type number. Yeah, so like the right whale call types like 5 through 9. If you're creating a new call library, you're probably going to start with call type 1. So you can create that. This new pop-up window here will have a few different fields that you fill out. So this is information that you can later access to when you just want to look up information about what call types are in your call library. So let's say North Atlantic right whale, name of call type, maybe a long up call, description of call type. You could say longer up call from whatever, 50 to 300 hertz. And then contributor of call type in there, click OK. And it will give you a new button here. So as you go through your data, page forward, because all these are, I should have added a Finwheel call type apparently. Let's say this one, not probably, but if you wanted to add that to your call library, you would click the button over here to assign it. So if you know right off the bat that you're going to be looking for, if you're going to be creating multiple call types, you could just add your call types, like add a few of them just to get some buttons on your screen, right?
And you can edit this information. So say you like want to change the description or the whatever, you can do this in the other program, manage call library after.
Yeah, so if we did that, there you go, you have a new button. So you can click through your data set. Again, you can use the jump button if you want to click to a new section where you have more calls, but when you click a call, it'll select that call as an exemplar to add to your call type. There's some just general information down here. So amplitude, frequency range of your pitch track, duration of your pitch track. Oh, this is call type.
So it'll show you, so on the screen, the call, the probability MDIST will show you, once you have a call library, it then shows you like the top matching call types, probabilities, and distances of that pitch track to what's in your call library. So let's say you want to add, 20 new exemplars to call type 5. You can see, is that more closely resembling call type 5, or maybe it's call type 6? And so you can kind of use that to help you, but I wouldn't use it until you have a very well developed call library, because as you're developing it, that's going to change. And that's the whole point of what you're doing, is you don't want to trust yet what the call library says it assigns to, because you won't have enough examples for it. Courtney has a question.
This will look better. Yeah, Courtney, go ahead.
Can you explain again what the colors correspond to, and if we should be choosing a variety of colored tracks, or just should we focus on a certain color?
You mean the color of the boxes or the color of the actual pitch track?
The color of the actual pitch tracks. Like, it's not the segments, right? It's referring to something else you said earlier.
It's just amplitude. So
okay.
So it'll show, so warmer colors are going to be louder versus quieter colors are going to be softer sounds. So like this up call here, most of the most intense part of the call is kind of in the middle here, and then the ends are a little bit fainter. And you will see that in your analysis. Like if you have some super faint calls, the pitch tracks might be, you might get kind of what we call them, like kind of partial pitch tracks, where it's just kind of, it's catching part of the call, but if the call is super faint, so you might still detect the call and get a pitch track, but the pitch track might just be a little shorter, or it might be, blue and faint. But yeah, so yeah, red would indicate like a pretty loud sound. I don't know, Mark, if you have anything to add to that one, but
nope,
yeah,
that was perfect.
Okay, excellent. Okay, I think that was most of what I wanted to cover with that program. So the last one that we'll go through today is the manage call library. So this is once you've added some exemplars to your call type, or if you have an existing call library and you've added new exemplars, this is where you go in to look at and evaluate the quality of your call library, and if you need to like delete some exemplars or move things around to different call types, whatever. So the only required field for the manage call library program is your call library file. So for this one, I'm gonna pull up the GOM9 one, so we have a little more to look at. So this is, you're gonna go to your call library folder and select the base file there. And if you know which call type numbers in the existing call library that you want to look at, you can enter those in here. I'm just going to leave that blank for now. But let's go ahead and open this. So this is, I think, okay. Leah, what we were talking about earlier, where you were asking where do you go to actually like look up all the information of your call library. This is where you can go to get kind of a summary of this. I wonder if I can just say none for now. It's fine. Is this gonna let me? Maybe not. You might have to scroll over. So so this provides you with a summary of the different call types in your call library. So we can see here, this one, it does have most of the baleen whale species that we look for. So aside from blue whale are not included, but we used to use this for fin whales. So fin whales are included. We now use the low frequency call library for fin whales. But so you can see call types 1 through 3 are sei whale call types. So they're just different variations of the sei whale down sweeps. If you keep scrolling over, so these are the settings that you input when you first add a new call type. These are the settings that that you originally entered, or whoever did when they created that call type. So you have your description of the call type here. You can see there, here are our 5 right whale call types. We do have a right whale moan, which is call type 10. Ooh, sorry, skipping around. A bunch of humpback call types. Obviously humpbacks, they change their song season to season. So your humpback call library may get somewhat out of date eventually. We haven't updated ours recently, but we do have some kind of core calls that do tend to show up in song over multiple years. And so it actually has continued to work well enough for us to be able to detect humpback with it as well. So, and you can always add, like if there's a bunch of new call types, you don't have to go crazy. Like if there's, you can add 1 or 2 call types that are just really common, and that might be sufficient for what you need to detect a species like humpback that are just highly variable. And then down here, you can see, this is a good example of the hard drive noise. So there were a few different pitch tracks of that hard drive noise from the Marus that we created call types for, so that we could filter that one out and not have it selected. This column here gives you the example of like how many exemplars were added to each call type. So you can see we're kind of in the like 50 to 200 range. You shouldn't need to add much more than that. Otherwise it gets kind of redundant, or it's not, you don't really need to. But you might want more than, like 30. So that's something you can play around with this program. So I'm going to close out and reopen this really quick. I know we only have about 18 minutes. Restore. Okay. Okay. So this is where I'm going to select a call type to look at. Let's look at just a classic right whale up call. Okay. So it's going to open up 3 windows and this little GUI box down here that show you all of the information for all of the exemplars or example calls that were added to that call type. So we're looking just at call type 5, which is a right whale up call. So this IDL 3 window, this shows all of your pitch tracks for all of the different up calls that you created. So it kind of just allows you to eyeball like what are all the different pitch tracks that you've added to this call library so far. And Jen, you might have to remind me if we can do it this way.
Okay, I can, yes, no, we can go through.
Yes.
So I don't think that window will expand, but in the GUI button, there's a couple of things that you can cycle through. So first, the other panel, so the IDL2 window, that shows you kind of how close each of the parameters, and Mark's probably gonna sorry, Mark, we're gonna push for this. Yeah.
If you want me to explain it, it's fine. I couldn't remember how to expand the window.
Oh, I don't think we can.
Is that you have to select, I think it's in the reference guide, actually. There is a way to do it. I think you have to change a call type. You have to expand it. wait, sorry, it's going to help me explain it if we're able to see it a little bit better.
I think you
so
just
you
have
kind
to
of,
redo the call type and then like reset it, and then it, yeah, you just have to like redo it. I did it yesterday.
Maybe
wait,
hit,
Manal,
hit,
you
a
were
new,
saying,
hit a new call type now, like expand it and then
Yeah.
hit the call type.
You don't even have to expand it before, I think, or maybe you do expand it before. Yeah.
I think you have to like drag it out to whatever size you want it. So the whole reason I'm sidetracking on this is because when you first open it, especially if you have a bunch of exemplars in your call type already, the exemplar numbers will show up and they'll be overlapping. So to do this, thank you, Manali. I was like, I can't remember how to do it. So to help that out, you can expand your window a bit like this, and then go over to your GUI, select change call type. You don't actually have to switch to a different call type if you don't want to, unless you do want to look at a different one. Select that same call type number and then hit OK, and it'll regenerate that window with expanded numbers. So this is this shows you all of your pitch tracks with their different each pitch track has a number, each exemplar has a number. And I'll show how to kind of navigate through that window shortly. The IDL2 window shows basically just like scatter plots of so when I describe the Mahalanobis distance as a multivariate measurement, these are some of the different measurements that it factors in. So it shows Mahalanobis distance here of all the different exemplars. And then it also shows, so this is like average frequency of the calls, and then standard deviation. There's, here we go, slope. So the slope of the call, of the up call, and then it also, to help it measure the call and match it to others, it will take the slope of the first third of the call, the second third of the call, and then the third third of the call, or the pitch track. And so that's what this like S1, S2, S3. So if you start adding a bunch of exemplars and some of your up calls have, a certain slope, and then some of your up calls are a little more shallow, you might start seeing like 2 clusters here, in like slope 2 or slope 3, maybe, of dots. So if you're starting to see that in this plot or in like the histogram plot things, you can, if you're starting to see like multiple peaks, that might be a sign that you might want to split that call type into 2 different call types. So same thing. So IDL 0, this window is showing essentially kind of the same thing as the scatter plots, only as a bar plot. So again, like if you have ones that maybe you have up calls that are a little bit lower, and then you've added some that are a little bit higher frequency, that would show up in your frequency plot here. So you might get like a double peak there, and that's a sign that some of your exemplars, you might want to move them and create a new call type and move them over to that call type. And so you can do that by using the GUI window. So we can do, like select case. If you click on that, it'll give you a little pop-up window. And that's where it's like, you do kind of want to expand this IDL3 window down here, because you want to be able to see these numbers to select which exemplar or case you want to look at. So let's do like 715 and click OK. And what that will do is it'll highlight that one particular exemplar 715 in yellow. So you can see it selected there. You can see it in this plot. It's really hard to see, but you can. There are yellow dots. It's probably easier to see on your own computer, and it'll show the placement of where that exemplar falls in comparison to all of the others. When you first add a bunch of exemplars to a call type, you might get ones that you might get outliers. I would add maybe 50, give yourself a good starting number of exemplars in your call type before you go in and use this manage call library program, because you're going to go in initially, if you've added like 30 calls, you're probably going to have a bunch of outliers, and they usually show up in red. And so if you're only partway through adding your exemplars, you don't want to go in and delete all your outliers, because it's just probably going to give you more at that point. You want to give yourself enough samples to work with for when you actually go into the manage call library program. And that way you might just have like 1 or 2 outliers, because if you delete an outlier, which if you want to delete an exemplar from a call type, you can use the delete exemplar one here, and we have 715 selected. So it'll say, are you sure you want to delete index 715? I'm going to say no, because I don't really want to edit this call library right now, but you can say yes. And if that was the outlier, it would have shown up in red. And if you delete that, there might be another outlier that pops up in that case, because it'll kind of shift your settings. So just be careful with the outliers. Wait until you've added a fair number of exemplars, maybe 50 to 150 or so, to your call type before you really start editing. So we're gonna say no. You can navigate between cases. So next case, back one case, we'll go from 715 to 714. Spectrogram view of case, you click that and it'll show you a zoomed in spectrogram of that call that's in the spectrogram. So it'll show you a picture of that that is zoomed in. Why did this change? Did I just delete something? Oh, quit. Oh, it didn't like it. All right, let's do this really quick. Okay. You can also play cases, adjust the speed and volume. Each one of these buttons is explained in the reference guide as well. This move case to a different call type is really helpful. So say we want to select, let's do 715 again. Select that call type, move case to a different call type. So this is where if you add all your exemplars and you start to see 2 clusters of exemplars on the scatter plot or in the histogram, which you'll probably see in both locations. And you want to start moving a bunch of those over to a different call type. That's how you can do it here. So you can select them. You want to say, are you sure you want to move to index? You can say yes. And it'll let you pick which call type you want to add it to. So you will need to like create your new call type before you do that. Here's where you can modify the call type information. So it gives you the option to do the species. I'm not going to go through the motions, but this does give you the pop-up boxes to be able to like edit that information that gets listed here in your call library summary. And any others that are important? Yeah, if you just want to, you can add a call type through this program if you want to. So if you want to add a new call type to be able to start moving exemplars over or something, you can do that here. Change call type if you want to look at a different call type. Maybe we can look at say whales. And it will regenerate. So now we're looking at say whale down sweeps. Same thing. And we have looks like fewer exemplars in this one. So this you don't need to expand the window for. List exemplars. This gives you in the log window, this gives you a list of all the exemplars that are included in that call type with the information about them. So you can access that there. I think that's most of the ones that you would use most frequently with this program. Loop through calls to compare. I think that's with the audio. That's another one where it'll play the clips of each call and it'll just like play through them so you can listen to all the different ones. Okay.
Yeah, and that one, it'll go back and forth. I believe it goes from like the one you're selected on to like the next one in the call type, and then it'll go back to the one you're selected. So it goes kind of through order, but keeps coming back to the selected one, I think.
I think so. Yeah, I think that sounds right. Again, described in the reference guide if you need to double check. Okay. I think that is everything that we went through. There are a few programs that we didn't actually display or demonstrate. So if you are wanting to look into any of those, they are all in the reference guide. So feel free to look through that. If you have any questions, let us know. The reference guide is definitely like, it's pretty comprehensive. There's a lot of information in there. So definitely check that out. Check out the training videos. There's lots of resources available. And then of course you can email if it's a really specific question to your own thing, you're welcome to email the three of us and one of us will get back to you. If it's more of a general one, the community is very kind. I know it is intimidating to email to like a mass group of people that you don't know. But everyone is kind of on the same page with this program and some folks have been working through it for years. They have tips and tricks that they've discovered as well. So it actually is like really helpful to email the LFDCS users listserv and have things explained that way, because it can be intimidating, but you're probably actually helping somebody else out because they might have not asked that question yet. So any questions? I apologize, we didn't leave a lot of time at the end, but happy to just, I know I can stay on for a little longer too, but any questions about anything that we've covered? Teacher wait time is kicking in. Okay. All right, everybody. If you need access to the training Google Drive, please email us, or the distribution file. The link is in the email that we sent out earlier. I think last week was the one that had the email with the distribution file in it, or a couple weeks ago. And so you can request access through the Google Drive link there. Yeah, I'm trying to think if there's anything else. I think that's about it. Jen, is there anything, or Mark, anything to add? I'm glad it was helpful, Courtney. Yeah, definitely don't sit and struggle. If you get stuck on things, look at the reference guide. And if that's not helping, please email us and we'll help as much as we can.